All right, today's problem is reverse linked list. This is the first one in, hey, welcome in, y'all. This is the first problem in the linked list kind of series. Let's actually just take a quick look at that. There's quite a bit of them. These are popular topic-wise, so we got 6 of them. They get progressively harder. The first few are mostly just like learning how to use linked lists. So yeah. I should note here, in case somebody is wondering, these are all going to be dealing with singly linked lists, which we could turn into doubly linked lists, but these are all solvable with singly linked lists. So yeah, let's take a look, and then we'll talk a little bit about linked lists as a data structure, and then we will go ahead and tackle the actual problem. Okay, so our problem today is reverse linked list. And here's the prompt. It says, given the beginning of a singly linked list head, we want to reverse the list and then return the new beginning of the list, which will be whatever was at the end with all of like the nodes pointing backwards from what they were pointing at originally. Okay, so for example, and this is not actually what the data is, so we don't actually have an array here, we just have a bunch of objects that resemble this array, but this is saying we have nodes 0, 1, 2, and 3, and they're pointing forward. And the output is going to be 3 at the front of the list, pointing at 2, which points at 1, which points at 0, which points nowhere. So it's not actually an array. We're not trying to reverse these numbers. We're just representing them using this array. Okay, example 2 is an empty list here, which if it's already empty, then we're set to go. We can just return none in this case, and we're using Python. And we're told that the length of the list will be between 0 and 1,000, and the values themselves, which we don't really care about, will be between negative 1,000 and positive 1,000. Okay, so let's just talk briefly about linked lists. All linked lists are their objects, which I'll represent as circles here because that's pretty customary. And in this case, they actually give us the definition of what a linked list node looks like. All it has is a value and a next, and the value is just a number that gets stored inside, so for example 0, and next we can think of as a pointer to somewhere. This actually is a valid linked list, so the pointer can point nowhere, but more often what happens here is our linked list is going to be composed of nodes that point at each other. So this next right here, we can assign it somewhere else, but all it's doing is pointing at another node, or by the time we get to the end of the list, it might be pointing nowhere, like that. Okay, so if we want to reverse this, well, what's the result going to look like? It's going to look exactly the same in terms of the nodes that are here, but they'll just be pointing backwards, so whatever was originally at the end is now at the beginning, and whatever was originally at the beginning is now at the end. There's not a ton to say about this, but we will cover a few different ways to kind of handle this in increasing orders of like preference. So we'll go with kind of the worst solution first, quote unquote, and then we'll improve it as we go. So if it looked like this, what we want when we're done is something that is pretty much exactly the same, but everything goes this way instead. Okay, so we'll have something that looks like this. And notice it is actually not sufficient just for us to like turn the middle pointers around. We also need for example, the last node when we're done to be pointing at nothing. And we also need to make sure that this guy doesn't like continue pointing at nothing, right? So there's a couple of like extra things we have to change, but all in all, the reverse is pretty much what you expect it to be. Now, here's the other challenge with linked lists. Like I mentioned at the beginning, we are representing them in the test cases as like arrays or lists, but in reality, we can't see like the whole array or the whole list. All we can ever see for a particular node is the thing that comes right after it. So we can't, for example, say, at least not directly, we can't say go to the end of the list, for example, and reverse that. We would need some other structure to say, okay, we need to track kind of where we're going, or we need to handle this just one node at a time. So that's the additional challenge. Okay, so a few ways we could handle this. We could go through the whole list, and using additional space, we could actually make an array out of this. So we could say, basically like start at the beginning, and make a list node that has a value of 0, and then a list node that has a value of 1. Or we could even just store the thing that we're currently like looking at, so we don't have to create a new one. We can just store the ones we were originally looking at, but something like this. And then we could just iterate backwards through this array and make this point at that, and make this point at that, and make this point at nothing, and then we're set to go. So this takes extra additional space. We have to like make a list that stores pointers to like all of the nodes, which if this is really big is a lot of space. So we would prefer not to have to store it, although we can do that, and we'll code it that way because it's pretty short. The alternative here is to store enough information that we can just reverse this one node at a time. So here's what I mean by this, is if we were looking at this node, which is where we'll start, and we want it to reverse this, what would we need to do? Well, when we're done, we want this guy to be pointing this way, right? Okay, well, here's the problem with that. If we immediately turn this pointer around, that was our only connection to the rest of the list, right? So that's something we want to do eventually, but we can't do it immediately. And in fact, turns out what we'll do is before doing that, we'll have some like temporary variable that points at whatever was originally the next node. Okay. We'll make this guy now, so the next step, point backwards. Okay, the other question is like point backwards to where? Well, originally there's a none over here, right? Like there's nothing to begin with. We'll make it point backwards at that. Okay, in fact, let me back up because I want to describe this in more detail. So when we get to the code, it's very clear. We're going to start by saying let's have a pointer for whatever the current node is, right? Okay. Let's have a temporary pointer that stores what the next node is. So I'll call this even like next. Because again, when we reverse that pointer, we don't want to lose where the next node is. And then we also need like a previous node, which initializes to none because there's nothing here at first. And this is going to let us refer to, hey, when I need to reverse that next pointer, I need to know what to point it at, right? Okay, so again, what we'll do is we'll capture the following node in a variable, right? We'll reverse this connection over here. So I'll say like, I don't want to erase it, so I'll just cross it out. I'll say you no longer point here, now you point over here to previous. Okay, and then we basically just want to shift these forward. So current is going to go to where next is, right? Well, we don't want to lose, again, if we move this pointer, we no longer have any way to refer to this. So actually what we want to do is we'll make this guy move over here. We'll make this guy move over here. And then to start the next loop, ooh, and then to start the next loop, this guy will go over here. And we can just repeat our process at that point, right? So again, the process here is that we'll store this guy in a next variable. We'll turn this guy around to point at the previous node. And then we advance. And how do we know when we're done? There's a couple ways for us to kind of capture this condition, but we'll know when we're done basically when there's nothing following. Well, let's think about this. So like we get here, there is no next node, right? So we could say like when current is pointing at nothing, or we can say like when current.next does not exist anymore. So a few different ways we can capture it, but I think the clearest way is just to say, hey, when we get to this situation, basically, ooh, what the heck? When we get to this situation, we know that we're done. And then part of the problem constraint is also returning the new head of the list, so whatever the last node was. And notice when we get to this situation, whatever is captured in prev at that moment is the last node. Okay. We'll go over kind of an idiomatic way to do this in code, and then we'll also do it recursively because it pays to have multiple solutions under your belt. So yeah, pretty straightforward as far as the logic goes. A little bit difficult to capture in code, but it won't be too bad. Okay, let's see if we can speedrun this a little bit. Okay, so option one, we can just say, so we'll have a current node, which is going to start at the head. And then, so the first algorithm we covered here was, hey, let's make actually a list of nodes. Okay, and then we can say like while cur, and so this is going to capture like as long as there actually is a node being pointed at and it's not at none, we can say node list dot append cur, and then cur equals cur dot next. So this is going to say store the node in the array and then move on to the next node. Store it, move on, store it, move on, and stop once you hit none, right? Okay, and then we can go backwards. We can say for, ooh, let me think about this. So we want to go backwards here, and we can do this by saying for I in range, ooh, len node list. So if there's 5 elements, for example, the last thing will be element 4. So we want to start at the length of the node list -1 and stop. So remember, what we want to do here is go 1 past the place where we want to stop. So we actually do want to process element 0. So we'll say -1, and then this second -1 says go through the list in reverse. So this is the step. So it says, this says start at the end, go until you hit the beginning of the list, and every step you go backwards by -1. Okay, so all we have to do here is say, well, actually, let me think about this, because when we get to the last node, ooh, now actually, well, let's talk about this real quick, just because I thought this was going to be easier than it is. One thing we also need to do is make the first node point backwards at none, right? So what we could do is we could actually say, go ahead and put none in the front and then put on all the nodes. And then this way we can safely process kind of the last one. And in this case, we don't have to actually handle the quote unquote first element because that's none. Okay, so this is a safe way to handle like referring to the thing before 0. Like we don't want to do that, so we can just do it this way instead. Okay. Sweet, so for I in range, let node list -1, stop when you get to the first element and go backwards. We can say node list I dot next equals node list I -1. Okay, and then when we're done doing that, we can just refer to the last thing in node list. So we can return node list -1. So this is a pretty straightforward way to do it in with some extra space here. Sweet, and I'll go ahead and submit just to make sure that this works generally. Great, okay, so this is one way we can do it, but again, it requires some extra space, so we'd like to do it without, and this is gonna require us to use that like 3 pointers or like 3 like storage variable solution, but that's constant, which is quite nice. So we'll still say, let's let current equals head, but we also need for previous to equal none. And this is because the first thing that we reverse, it's going to point backwards at nothing. Okay, and then we'll do kind of something very similar here. We'll say, while we're actually looking at something, what do we need to do? We'll say next, ooh, I forgot that's a keyword. So like next node is going to be whatever was originally next, right? So this is us storing the next thing we need to reverse, the next node we need to reverse. Okay, now current is gonna point back at previous, which is fine because we've captured what it used to be right here, so we haven't lost it. Okay, and that reverses this individual node. Now what do we need to do? We need to shift everything forward. So now prev is gonna equal current, and then current is gonna equal whatever was originally the next node. Okay, and this eventually gets us to the point where we've hit the last node. We've passed it even, right? And then we realize, oh, we can stop now. And at this point, we can return whatever's in prev. Because again, if we're saying while cur, we stop when cur is like right past the end of the list. I think that's it. Let's see if I messed anything up. We are good. Okay, so last thing we're gonna do here is the recursive solution, which low-key hurts my brain. But we're gonna try it. Let's see if I can get it from scratch. Okay, so the recursive solution is basically asking us, like, for any given node, like, what do you need to do to reverse it? Now, we can't, I'm gonna make a helper function here because, like, I don't want to keep manipulating. Well, actually, could I just do this? We would just need, like, head to be a new function, right? I guess we could do that. Okay. I'm not sure if we need a helper function, but we're going to find out again. Oh, no, you know what? Actually, so, like, in our previous solution, we actually had an explicit variable that referred to the previous node. In this case, if you're, like, using just this function, you have no way of knowing what that used to be if you're doing it recursively. Like, at any given layer, the only way to know is to pass it in, right? So we actually do want a helper function. So I'll say, like, def reverse list helper. And this is going to say, like, I'm going to give it prev and cur. So, like, tell me what the previous node was so I can hook current up to it. And then recursively call this on each future element of the list. So basically what this is saying is, like, push it till the end. Like, don't start reversing till you get to the very end. But then we can kind of unfold that all the way back to the beginning. Okay, so what are we going to give it? I'm going to say self.reverse list helper, and when we start, we're going to give it none and head. And we eventually need to return the new beginning of the list, so we need to kind of set this up to do that. So what are we going to do? Well, we can say... Well, okay, we're going to put our base case here. I'm going to leave this just as a comment because we can figure it out later. What else do we need to do, though? Well, for any particular node, if you want to reverse it, all you have to do is say cur.next equals prev. But like before, we don't want to lose that because we need to pass it along to the next part of the function. So we could say, like, ooh, wait, hold on. I'm realizing we need to pass, so, like, we can't pass back anything we want. We want to pass back, like, the last thing in the list. So I'll say self.reverse list helper cur and cur.next. Now, I do need to, like, return, like, eventually we'll get to a base case where we actually return the last element, but I can't put this here like this because then it'll never get to the next stuff, right? So we could temporarily store cur.next. Oh, let me think about this. Let me think about the most elegant way to do this. This should work as long as we... Yeah, okay, so I want to actually put this at the end because I don't want to return until we're, like, done, right? So what we can do is we can say, it's pretty similar to before, next node is going to be cur.next, so that we have access to that thing before we cut it off here, or before we reverse it, right? Cur.next is going to be prev, and then we will return, instead of this, we'll return this. Okay, so what this is saying is, assuming, so, like, base case is we've reached the end of list. So assuming it's not the end of the list, all you have to do is store what the next node to be processed is, reverse the current node, so have it point backwards, and then basically this says reverse the next node, or reverse the rest of the list. Okay, so what's the base case? Well, we could say, like, if not cur, is that sufficient? Yeah, I guess so. If not cur, what are we going to return? Prev? So this is literally the same logic, just implemented recursively. I think that's it. Okay, return prev next. Yeah, I mean, seems to do the job. And then, so all the recursive base cases, or all the recursive cases, will finish out reversing the rest of the list and then return whatever they got. It's not until we hit, again, the thing after the end of the list that we return prev, and all of the other layers just return that, because it's the only base case. So I think that works. I guess we're going to find out. Ooh, feels good. And so again, all we mean by recursion is like, let's have the function call itself. This is fundamentally the same as just passing along like that current pointer, just implemented through functions. So each of these functions isn't complete until it reverses the rest of the list, or reverses the next node in the list. Or if we get to the end of the list, we can just stop. And then all of these examples where we said go ahead and reverse the rest of the list, those all finish up, and they also pass back the end of the list from here. And so way back over here where we originally called it, this is now going to return the end of the list as well. Sweet. So yeah, this is classically recursion in the sense that all it's asking is like, how do you do this step, and how do you pass it along to the next step, and then where do you stop? If we can answer those three questions, we can implement recursion. Great. That actually took a little bit longer than I expected, only because we did a few solutions, but that's day one. I'm so glad it went really smoothly, because last time I did this, I literally spent like hours on it and like got super lost. So sweet. We'll call it there, because I'm assuming my goat, who definitely knows how to do this and is definitely going to post his solution in the day 19 thread, knows how to do this already. So yeah, have a great night, and I'll post the recordings. I keep forgetting to do that. I will do that. Okay, bye everyone. And by everyone, I just mean Sid.